The first book, which was Electrical Symbols and Circuits, uh, I've been writing my home study course, and I need videos to go with those chapters. And so I wanted to go over some of the material with you guys in video form so that you're not just reading and you're like, okay, I see it, but I don't understand it. And when you read it, you got nobody there to ask a question about how it works. So this is going to be part of a multi-video series I'm going to do for the next couple of weeks. I'm going to go over schematics at a very, very simple, like, what is it? And when I'm looking at it, what am I looking at? How do I understand it? Till we go up to full troubleshooting and using it with the appliance, which, you know, I'll promote my boy Samurai. I think he did a diagram one today with hands-on. I think I have a video similar to that where I had a dryer and I had the diagram in the background, and the dryer was up on a table and I was hooking up the meter and saying, here we are in the diagram, here we are in the machine. But still, if you don't understand what you're looking at in the diagram, this is difficult. I put this diagram up because I've lectured on this, and we're going to get into these types of diagrams and explain everything, but we have to start with the basics. So let's just take a look at this. I'm going to use a little bit of the book, but the book was more for you guys to practice and do on your own. It has like questions in it. We'll go over some of them today. And then at the back of the book actually has all the answers. And so we'll use those books as we go on. And as I use more diagrams, I'll send those out also with the emails. So let's take a look at this wiring diagram. This is the very first question in that book. It says a wiring diagram is similar to a road map. The lines on a road map show you where you can travel. The lines on a blank diagram show you electric current can travel. A lot of my new students, this is one of the very first books they go through when they're learning diagrams of electricity and everything. And they don't realize that question was written like in an elementary school type hardness or whatever, you know, level. It's just very simple. The very first 3 words or 4 words says a wiring diagram is similar to a road map. So the answer was lines on a wiring diagram show you where electric current can travel. So here I was comparing a wiring diagram a little bit to an actual map. That these lines show you where cars can travel, and so these lines are showing you where electricity will travel in a wiring diagram. And we need to look at them and understand the flow through these components. We'll break it down piece by piece. So the thicker lines, and then you got even smaller lines, and that's the same thing. Like if we go back to that stove for a second, if we looked at the stove, we got some real heavy wires, and then you got some smaller wires here, and the heavier wires allow the machine to carry more electrical current. So in our map here, we got big lines and then we got small lines. Well, what do the bigger lines represent? The freeways and expressways that handle more cars. And then the smaller lines are just our neighborhoods, and we don't have as many cars flowing through it. And think of the cars running on those roads as electricity flowing through the wire. So if we look at this map, over here in the upper left-hand corner, I got point A, okay? And over here I have point B, which is actually, this is where I used to live, and this is a mall called Pembroke Lakes Mall, and it's an actual map. So if you were to leave this apartment, and follow me here because I'm trying to get to something, you would take this road and you'd get on this main road, you hit the light, you go in here, and you're in the mall. Okay, that's electricity flowing in a circuit. But what about when you want to go home? Okay, do you take the same road back that you came up on? What do you guys think? Or do you take a different road? Any ideas there?
You take a different road. You're going in a different direction.
You're going a different direction. So if we looked at this here, look at the blue line. It's technically the same path or how to get there, but you're on a different road, right? You're using a different road to go back as you are going to the mall. And electricity is the same way. If we go to the light bulb circuit, you can see here we're going one way to get to the mall, all the way in, and then we're using a different way to come back. Electrical circuit does the same thing. We have one line going into the light bulb, and then we have another line coming out. And all parts have to have these two wires, whether it's line 1 and neutral or line 1 and line 2 for 240 volts, that you cannot have just one of these wires going to a part and that part will work. So when we are troubleshooting circuits, we have to understand, okay, where is the electricity? How does it come into the part? How does it go out the part? And then you can see in red, this is line 1, goes to the switch, comes out the switch, and then goes to the bulb here, and then comes out the bulb this way. So how does this relate really to a wiring diagram, and how do we read those things? Well, using these symbols in a wiring diagram, these symbols are just quick little sketches or drawings of the parts, and to understand the diagram, part of it is understanding, when I look at this symbol, what part is that? And if I go look at the appliance, how do I know that this is that? And here's a symbol. You know, if you saw the skull and crossbones on something, you probably wouldn't drink it, you know? But it stands for poison. But it doesn't have the word poison right there, you know? It doesn't even have the word poison here. It does on the outside of it, but someone might look at poison. What the heck is a poison? I don't know why they did it that way, but they want to let you know it's poison. So let's look at these symbols. It's symbol for a railroad crossing, right? Symbol for a stop sign, for a yield. You guys see them every day and you don't question what it is. You know what you have to do when you see these signs, whether you have to stop or there's a train coming, or yield probably means you're going to go into a lane with other traffic and we have to be careful. So what happens if you saw them like this? Would you still know that one is a train track and one is a stop sign and everything else? So you didn't need all these words and the color of the paint to tell you that. And again, I'm trying to break it down. When we're looking at symbols and stuff on wiring diagrams, we have to go just to the shape and what does that mean? It's almost like Braille or some other type of language, right? So let's take a look at this. Here we got a picture of a plug, light bulb, and a light switch. This is actually what those parts look like, okay? What type of symbol are these? We have two types of electrical symbols on wiring diagrams. Does anybody know what type of symbol they are? I'll give you a second. They're pictorial symbols. Pictorial symbols are pictures of the part. I mean, like, if I put this plug next to that picture, would you think that's a drawing of that plug? If I saw this light bulb, would you almost identify it immediately? And this switch. And wiring diagrams can be drawn with symbols like this, but if I asked all of you guys, okay guys, I'm not going to show you those plug, light bulb, and switch in the top there, but I'm going to show you the pictures on the bottom. Now I want you to draw me a picture of the plug, and you draw me a picture of the light bulb, and you draw me a picture of the switch. A pictorial drawing, like we have up there. But if you never saw those, do you think all three of you, your images would all look the same? No, none of them would be. And that's the thing, is manufacturers have a little bit of a latitude. So in one manufacturer, it looks like this. Another manufacturer, it doesn't look that way. So you're going to have to, you know, get an idea. What does this symbol mean? What does it look like? And pictorial symbols are easier than just a schematic symbol. Schematic symbol doesn't have, like this light bulb didn't have all this fancy drawing inside of it and everything else. It just was a shape, almost like the yield sign here, just a shape. And you have to be able to identify those shapes. So let's go to this plug here and talk about how this plug works, and then we're going to go to the schematic symbols. You know, it's funny that I was talking about the voltage drop, but my class I want to like I want to break everything down just to the simple basic, because the more you understand how every single one of these things work, this also gives you information. Like if I have to troubleshoot, like where do I begin and what I look at? Well, if I know how it works, I'm going to check this, I'm going to check that, and everything else. So this is just a replacement plug, similar to the one we had in the first picture. Now you see it's just got two wires connected to two metal pieces here, which are these prongs here. And when you stick them in an outlet, they make an electrical connection to the inside of this outlet. Now, how many times have you ever plugged a vacuum cleaner or something in and you're vacuuming and the plug is so loose it just falls out of the outlet? I don't know if you've ever seen them, but sometimes the inside of these plugs, they're like a U shape, and then you got the prongs that go in there and make connection. And I'll show you a close up of it in a minute. And that's how it holds it in there, is by pressure. If it's loose, the more you use it, the more it's going to burn, because that goes back to the problem we have with the oven. If it's loose and still touching, electricity will flow through it, but it creates resistance to that point because it isn't a good connection. And that resistance causes parts to run hot. If you had a customer's house that a circuit breaker kept popping, but it wouldn't pop immediately. They'd run a washing machine 4 or 5 loads, and then the breaker would blow. You know, and they'd wait a little while, reset it, and then the washer would run more loads, and it would blow. I would go to the actual circuit breaker, put my hand on the breakers, and feel them. And if that particular breaker is running real hot, it could be the breaker itself is bad. Because when you have a loose connection, it gets hot. It creates resistance. What does a heat element do? It has resistance, and when electricity flows through it, gets hot. So that's what causes these outlets to go. Now, again, I'm just going to break down a little bit of outlet because we're going to get to the power cords here. When you look at the outlet, you have gold screws on one side and silver screws on the other. And then you have like a greenish looking screw, which is here on the bottom. This is your ground. The silver screws, and you can see the silver ones on the left here, the silver screws are your neutral, and the gold ones are your hot. Now, real quickly, if we look inside the outlet, if we look at these openings here and these two openings here, that's where the plug is making connection inside the outlet. And this is where your electricity is coming from. So they only have one black wire here and one white wire here, but if it was just one outlet, that black wire would be here, and it would make connection to the top and bottom outlet. And then this one here is the neutral, make connection to the top and the bottom outlet. So if we look at these holes, do you know what these holes are? They're the ground.
Yeah, that's what I was getting ready to say.
Oh, I'm sorry. You took too long to press a button. But if you look, the ground is connected to the whole plate here. Even the center screw of your cover screws into that ground. So it is ground. If you were trying to check line 1 to ground, it'd be the small one is line 1 on the gold side and ground here. But let's just say that you couldn't reach in there with your meter. You could touch the center screw there, and that would be ground as well. But the point I'm trying to get is electricity is connected to these two screws, and then this is just like a wire inside the outlet. And then when you plug something in, it just touches metal against metal, and then the voltage comes out these two wires here to your appliance. Okay? So again, like I said, I'm starting off very simple and basics, and we're going to go all the way up. So this is part 1 of several classes that's going to get more and more in depth as I break down these diagrams and the components that make them up. So here, just real quick, you can see this. Is this the line 1 or neutral side?
Line.
It's
Line
the line
1.
side. If you couldn't tell by the colors of the screws, the actual ground screws on the bottom where the ground holes are, and it's on the neutral side always. So if you don't have a ground on this side, you know you're on the hot side. But if you look here, one last thing I want to tell you, again, just understanding the outlet, is this little metal piece here. Does anybody know what that metal piece is for?
That's the piece you can break off and control different things from the bottom to the top.
Yeah, so in other words, you have line one, it would go directly to this screw. If you didn't do anything here, it would feed the other screw, which means it feeds both line ones on the two outlets. But if you break it off, you could put out line one here, and this one could run to a switch in your wall. So like in your bedroom, you might have an outlet that half of it is connected to a light switch. So when you walk in the room, you hit a light switch and turns on the light in the corner of the room. That's how they do it. That light switch is connected to one, and they break this in half so the other one's power all the time. So let's move on to the outlet. So we would take this plug, and we're just gonna, let me reorder it, bring it to the front. That if we would plug it right in there, it would make connection, and then that would go into our appliance. So let's go ahead and connect these. I'm gonna go ahead and start with line one here. Let me get my tools here. And line one's gonna come in, and it's going to go to my plug here. That's when I plug it in, and line one's gonna come out. Where's it gonna go next?
Switch. I mean, what are we doing now?
We're
What are we?
going to complete this whole thing. We're going to connect the light and the switch and bring it back to the plug, like physically see how they're all connected. Then we're going to go back to a diagram and talk about it.
It's got to go to the switch.
Yes, right.
Does it have to go to the switch?
Not necessarily.
No, the switch could be on either side of the circuit, but
Oh,
code, I think, requires the switch to be before the light bulb, because this is power all the time. If you grab that wire, you're going to get electrocuted. This is neutral. If you grab that one, it's like ground. You're not going to get hurt unless it's connected to the appliance. But if you connect a switch before the light bulb, when you unscrew the light bulb, if the glass breaks, you touch these metal filaments, you could get electrocuted. But if you have a switch here and you didn't unplug it like you should, that switch acts as a safety before the load. So we're going to go in here with this line, and we're going to go into the switch. It's going to go through this switch, and it's going to go to the light bulb. Now, does it matter where it touches that light bulb? You
No.
muted yourself, Trinity.
Yeah, yes, it matters.
As far as what?
Well, if that's your positive, it's going to go on the bottom of the light bulb.
Yeah, usually this little black piece on the bottom is like plastic, and it's an insulator that separates the very, very bottom of the bulb from the threads here. But when it comes up, it comes up through this metal, and it runs through the filament, and then it comes back down and runs out the outside. And then this one's going to run right back here to the neutral. Oh, that's simple, right? Did I do it right?
no.
What happened?
You didn't connect the switch. You didn't connect the plug.
Yeah, I didn't connect the neutral side of the plug. So actually it would go here, and then this plug would get the neutral, right? And that's a circuit. You say, well, why don't they do most diagrams like that, or use the pictorials like we have here? Because it's okay if you only have 3 parts, like a lamp. But some of these appliances, have you seen some of these double wall ovens with the microwave and seen the wiring harness inside those things? Just imagine trying to draw it using pictures as big as this and try to follow circuits that way for troubleshooting. You could to a point. And if you're real good, you might be able to figure it out. But really what you need to do is you need to learn to read the schematic of it. So if you see here, this is a pictorial of a plug. Well, this is how they do it on a wiring diagram. They just use 2 arrows. So I'm going to rotate it because usually they're drawn vertically like this, but it doesn't matter. You can put it any way you want. And it just represents these 2 prongs. What do I need to draw this for if you could identify this as the power cord coming in? Now the light bulb, You see the light bulb looks like the picture, but this is that same light bulb. Now, symbol-wise, it would be easy if I asked you guys to duplicate those. But if I asked you to draw some of these, some people say, I can't draw. I'll try, but it's not going to look like that. And that's why the symbols made it easier, because they were less complicated. They were easier to draw. And, you know, when electricians wired houses, sometimes they actually drew wiring diagrams of those things as they wired them. And then this is just a switch here. And those two prongs represent these two prongs. These two represent the center and the side. And these two represent the two pins on the end. But it's not drawn that way. But you need to understand that if I'm checking this part and I wanted to check the resistance of this bulb, in this diagram I touch these two circles, but in this case I'd touch this pin and the side pin is the same thing. So let's connect these into a diagram. So I'm going to move the light bulb and the switch here, and we could draw that horizontally or vertically if we want. So we're going to come off of this from here to here. So this top one would be what?
Line.
That'd be the line. And then we go into the switch. It goes through the light bulb, just like here. You see it goes through the light bulb. If that filament broke, it wouldn't come out the other side. And then this case here. Okay, but they both look pretty simple. There's no complicated to that. And, you know, I'm not trying to get real difficult, but they're the same exact thing. The top one and the bottom are the same exact thing. They're just drawn differently. And these are the ones you need to understand. There's very few manufacturers now that are using pictorials. I think Frigidaire stoves still have a pictorial and a schematic. And I do have some of those diagrams we're going to get into. But now look at this diagram. We've added a few more parts. Now look at that diagram closely. First of all, where is the power source coming in on this thing? Where is power coming in?
Left.
The plug, right?
Yes.
Okay. Well, the parts of a diagram that do something as far as work, light bulbs, heating elements, motors, water valves, you know, if you actually looked at all the electrical parts in our machines, you'll find out 90% of our machines all use water valve, motor, heater. You know, they all use the same parts, just sometimes they're a little different and everything. But those are called loads. Loads are the parts that when you go to someone's house and they say, my machine's not draining, my washer's not washing, my refrigerator's not making ice. Every one of those is one of those loads in that machine is not functioning. Not draining is a drain pump. Ice, no ice maker, you know? And when they're talking, they're already telling you what part of the machine's not working unless they say it's dead. But in this diagram, how many loads are there in this wiring diagram?
One, two, three, four, five.
5. 1, 2, 3, 4, 5. But look at the light bulb over top of this heater. They had to put the word cabinet light there, and it blocked the circuit. Now, there's how many controls are in this circuit?
One.
One switch. Question: what is it controlling? Everything?
The cabinet light, the heater,
So it's controlling the heater?
and the cabinet light.
Which one?
Both of them.
Both of them. Very good. So power's coming in here, and it goes through this switch to feed the light bulb and out. It's going through this heater and out. It's going through this light bulb and out. But what about these two? What could you tell me about those two?
As soon as you plug it in,
They're running all the time.
yeah.
Okay, so there's nothing there in that diagram that says as soon as I plug it in, those two are running all the time, and the other three are only on when the switch is turned on. But you see how what little information you know about the diagram, how, like, I look at a wiring diagram of a brand new machine I never worked on, and I can understand 99% of how the components are working. This one does this, and this one does that, and this one comes on next, and then this one that. And again, it's like reading Braille. You put your hand on it, you feel it, and it tells you you're on the third floor of the elevator. Well, this is how we have to look at it. We have to take little pieces and then little by little read what it's telling you. Not the words, but the circuits and how they work, okay?
Mm-hmm.
So let's take a look at this. Is this diagram on the left the same as the machine on the right? All these images, by the way, are out of that book that I sent you. Okay? If you guys didn't have a chance, because I know I sent it late last night, before next class, try to do that first book, because I will have more stuff to go with this part one.
I'm gonna say yes.
It's close. Okay, so we got a motor. Where's the motor on this machine?
To the left, the first one on the left.
Yeah.
Where on the left here?
Right there, right there, the bottom.
This?
Yes.
That's a compressor.
No, right above that.
This?
Yes.
There you go.
That's your relay.
Oh man.
This is a compressor and that's your relay. This is the line coming in, and this is your main and your start winding coming off your relay.
Oh, okay. It's hard to see because the print's so small.
I'm sorry. You got the book, though. I sent you all the book. That image is in the book. Hold on a second.
Well, I ain't had a chance to pull that up.
No problem.
I'll be so busy.
But that's why I want you guys to practice it. Give me a second here to bring up an image, okay? So if you look here, this right here is line coming in, and the two holes on the other side is the run and the start. That's that relay. Okay? So let's go back to the Nang. So this is our plug here. Here's our plug. We got two light bulbs, right? We got two light bulbs. So we got a fan. Where's the fan on this?
I don't see it.
I don't see it.
Is that thing in the middle, right by where it comes out of the light bulb? Right there. Yes. That.
It could be a fan.
I mean,
I was thinking it was a timer too, but I think it is the fan. So we'll call it the fan. What do we have here?
A switch.
Switch.
We have the light switch, and we have one heater inside this box. Let's see how good you are. How many heaters are actually in this refrigerator?
Two.
Yeah.
Counting.
1,
Three.
3. Yeah, I see it now.
Oh, 4. No, it's 4.
Keep counting.
It's more.
But look what pictorial does. You know?
1, 2,
let's do it. This is 1, right?
3, 4.
Here's 2,
4.
right? This is 3.
4.
Here's 4. And what are these two dots?
Oh,
you got me.
The mullion or the style heater. Instead of using a hot gas loop or Yoder loop, that's actually a heater.
Oh, okay, yeah.
So yeah, you were right. You're right, Trinity. That diagram on the left is sort of at the machine, but it isn't really 100% that machine, is it? We didn't see the relay. We didn't know there was 5 heaters according to that diagram. We only knew there was 1. But, could it have been drawn easier? Yeah. A lot easier if we went to a schematic drawing. Now, this again isn't that refrigerator 100%, but let's read the question first and then we'll go. Many wiring labels show a pictorial and schematic wiring diagram. The blank diagram is more compact and easy to trace. Well, which one is more easy? Schematic. Now, is this thing drawn exactly like that diagram on the bottom? I mean, like the way the parts are working? So going back to the beginning, we said the motor and the fan, what happens? They do what?
Oh, they're always on.
They're always on. So if we looked at this circuit, and let me just use a marker so it'll be easier to follow. Power comes in and goes to this motor and it's always on. And it goes to this motor and it's always on. There's no switches, and that's the same as this. Does it matter whether I put these two on the top and this on the bottom? No. As long as I know how they get power and how the power gets to them, and are there any switches turning it on and off, then I can use that information of saying, well, if one of those motors aren't working, it has to be a bad motor. Because if the other motor's working and one isn't, let's just say the bottom one's not working. Okay, let's say the bottom one's not working, but the top one is. Well, I mean, unless it's a wire, the only thing it could be is a motor. There's no switches, there's no nothing. But if the motor's working and the lights and the heater are all not working, what's wrong with my circuit?
A bad switch.
Bad switch.
Mm-hmm.
What were you going to say, Rick?
No, I was going to say the same thing.
Yeah, so it's like if that switch was bad, none of them would work. But what if the lights were working but the heater wasn't?
Light was working, but the
The heater could be broken.
The heater's pretty much the only thing, or a wire. So again, all I'm trying to introduce you to is like, how do I look at this diagram? Okay, if this is working and that's not working, then it can only be this, or it can only be these things. And this is how we use diagrams for troubleshooting. Now, the other videos and lectures that I'm going to do and record for this hands-on thing that I'm, not hands-on, but the online class that I'm building, is I'm going to go over every little part of the diagram. If we went back to the image here, let's go back here for 1 second. Diagrams, not only do they have the the actual diagram, this is a schematic diagram. But what is this on the right hand side?
Like a strip circuit?
You strip circuits, and sometimes they call it ladder diagrams, depending on the manufacturer. And what's the use of a strip circuit? I think I used this diagram once before in a lecture. How would we use the strip circuit versus a regular circuit based on what we just did on the troubleshooting?
You know where to put your meter. You know where to test.
Yeah, because like if I wanted to know, let's just say this motor, how did power go through this diagram for this motor? Well, I'm going to go down line 1. How do I get to that motor? Well, let's see. I guess I got to go L to M. And the nice thing about this diagram, L is line and M is motor. So it goes here, but that's open right now. And it's going to what? What is this?
Switch.
Push the start switch. It's actually, on that timer, you push the actual timer knob as the start button for that dryer. It didn't have a separate one. And that fed the motor. And then we went through the door switch. We had a thermal fuse and out. So we have what? 1, 2, 3, 4 switches, right? And to find that circuit, you have to really be good at diagrams and trace it all around to feed it. But if I just wanted to do the motor, we go over here and we look at the motor, and this is to start it up. We got 1, 2, 3 switches. Well, wait a minute. 1, 2, 3. What am I missing?
Mm.
Out of this diagram I showed you, there's 3 on this motor, but I had 4, right? So let's do it. L to M timer switch. This is the L to M timer switch, right?
Okay.
The next thing is our start switch, right? And
Mm-hmm.
what do we have here? Start switch. Then it comes the motor. And we got the motor. And we got the motor, we have the door switch, and we have the door switch here. What's the next part here?
Thermal fuse.
Thermal fuse. Is it in this ladder diagram?
I don't see it.
It's implied. Oh,
But look, they drew it that way because that thermal fuse controls this light, this motor, and this. They're both the same motor, just the start and the run circuit, and then the motor down here as well. So they just drew the thermal fuse one time. But look, you have to be able to follow that circuit and read that diagram. But if I wanted my motor to start, and this is the start winding, and we need to send power to it, I either go check the motor, and it tells me what 2 pins on the motor to check. I'll make it a little bit bigger for you guys. Hold on a second. Let me just expand it. And if we look here, it actually tells you 1 and 2 on the motor, or 7 and 1. I think that's 2. I don't know. I'm sorry that's a blurry picture. I only brought it there for effect, just to because it had so much stuff on it. But when we're doing diagrams, a ladder diagram is not on every machine. Very few people actually use that nowadays, even though it's very helpful for troubleshooting. But the Whirlpool VMW washer, they had something very similar to it. And I'm going to show it to you before we end today. So let's go back to where we were. I'd like you guys, if you had a pen and paper, how could you make that diagram even more easier to understand? Redrawing that same diagram, what could we do to make it more simplified?
Instead of putting the actual wording, it's like you said, I call it pictogram. That's what I
You're
call
talking
it.
about like switch and light and heater and motor and remove that. Yes, that
Yeah.
make it, but what if you've never seen that symbol before? You're like, oh, okay, I don't know what to do now, but I could do this. Watch, it'll take me a second. I'm gonna hold on a second. I'm trying to. Oh, there's my snipping tool. I was trying to get it to pop up and it wasn't coming up. So, what if I do this? I'm gonna take the first. No, you know what? Let me stop for a second. Let me just draw these 2 lines, okay? 1 and 2. Line 1 and neutral. That's this line and this line, right? I need those 2 to make it work. And I'll put arrows here. Do I need to put them close together to tell you that those are the plug going into the machine? No.
No.
I'm telling you now, you need to know when you see a diagram and they're not close together, it's still the plug, but they're just showing it here, you know? Okay, so we have a light heater and a switch. And notice they put the switch on what side of the diagram?
right.
On the neutral side, didn't they?
Oh,
Now, if we go back to the other diagram, they didn't really have it on the neutral side. We don't know. Because since it's a 2-prong plug, we don't even know which side is line 1 and neutral on it. Usually the smaller one of the 2 is neutral. I mean, sorry, line 1. But they have it drawn here what it looks like to be line 1. But we'll follow the way they did it. And so I got how many light bulbs? 2, right? So I'm going to change color here. I'm going to go like this, and I'm going to add a light bulb. Like this, I'm going to add a heater. And this, I'm going to add another light bulb. And I'm going to do this. And I could do it here in the center if I want. Is that the same thing as this?
Yes.
Yeah, it's just drawn differently. But isn't my way a little bit easier to read because it's not making so many turns and everything else?
Mm-hmm.
And then if we really want to make it easier, here's the motor. another motor, and out. Now, I could draw it differently. I could do this, watch. Oops. What if I did this? Is this the same thing? Is that the same as that?
No.
Yes and no. Electrically, it is the same. So give me a second here. I want to do something. I want to bring something in here. Okay, I'm gonna get a motor here and bring it in. Oh wait, I had the wrong tool. Let's try that again. Okay, it doesn't want to work for me. 1 second. Okay, I'm trying to copy this image, and for some reason the image is not working. Let me find another image for a second here. This one might work. There we go. And let me copy it and paste it. So let's move this out of the way. No, I want to just get this. I'm gonna make it a little bit smaller, and then I want to say something. Come on, it doesn't want to move for me. Here we go. So in this one, the two fan motors are right over top of each other, and I got line 1 and neutral, and I got a wire going here, and I got a wire going out, and I got a wire going here, and I got a wire going out. That is exactly how it looks there, correct?
Mm-hmm.
Right?
Mm-hmm.
But what if I did this? Isn't it not still line 1
It is.
and neutral?
Yeah. Mm-hmm.
Now, in reality, in a machine, we have something called wiring harnesses. And remember, I went back to the stove where I said we got a big wire. So this wire here, technically, would be a larger wire up to this point. And this would be a larger wire here to handle electricity for both parts. But these wires don't have to be as big a thickness of wire. And when you look at appliances, thermistors and sensors and other components that are low voltage, they're real thin wires because they don't need to carry as much electricity. But it's the same thing. But if these two were, let's say, a compressor and a condenser fan motor, do you think they're going to run two separate wires from the plug? Let me see like this. Let me clear all my drawings here. I'm gonna bring something in here. 1 second. So if this is the plug, do you think they're going to, from the factory when they build these things, run one wire here, another wire here, and another one like this if both of these parts are right next to each other in the appliance? Just think, it could be 3 feet away from the power supply to that motor. So I would use, what, 12 feet of wire to feed these two fans? No, what we're going to do is we're going to tap into this power supply here and run it this way. So now I'll use a foot of wire. And so I went from 12 feet down to 4 feet or 6 feet or whatever. And it don't sound like much, but when you make 1 million appliances and you cut 1 foot off of the amount of wire that machine uses, you saved 1 million feet of wire. That's money. So that's why sometimes manufacturers make that wire so tight it just barely plugs into the part, and why don't you just give me an extra inch? Because an extra inch times 1 million is, a lot. So when they do these appliances or these diagrams, they don't draw this how we physically see it in real life. What they do is they let you know how power gets to it. And if I was testing this motor, I would know that there are no switches in this circuit to the motor like there are switches in this circuit to these components here. And that is the main part of the class that I wanted to give you today is let's take the diagrams and get down to the very little nitty-gritty parts so that when we're troubleshooting, you know, we understand all the little things about a diagram. Okay? I wanted to go real quick to the VMW washer. I think I have that book on my drive. Just give me 1 second here. Let me VMW. Okay, I do have it. So that's let me just bring it into the window here. You guys can see it on the screen here.
Yep.
So remember we talked about that ladder circuit or the strip circuits. So if we're troubleshooting this, I noticed the VMW washer does it on their electrical parts of the circuit. Not many manufacturers do this, but this is in their manual. I'll get to it one day here. Excuse me. And it's not showing me. Where is it? I don't see it. Dang it. It's not in this book. Give me 1 more second. I'm gonna check here. I got some other VMW stuff here. Let me see if it's this one. No, that's not it either. So it's not that book. It's an older VMW washer book, but in the diagram, they have like strip circuits, and I was hoping to show you in that book, but the book that I had open wasn't the same one that I was thinking about. I could have sworn.
Well, the tech sheets do, it seems.
But like when you go to the here it is. I found it. So here, like if you're doing the main motor, they're just showing you the parts that are in the circuit of that motor. So it's nice here. Here's the shifter motor assembly. Your shifter didn't work, and you want to know what components. Well, look, are there 2 main control boards on this machine? Looking at this diagram. Oops, I'm sorry. I didn't want to go that far away. I wanted to zoom in so you could see it, and I left that screen. Here, are there 2 main control boards there?
No.
Well, it says main control here and main control there. What's going on?
It looked like they line 1 where it hooks to line 1 and neutral where neutral comes in at 2 to the board. Am I right or wrong?
The number.
Yeah, you didn't explain it fully, but let me just do this real quick. I'm gonna take this and carry this into the other program here for a second. So let's look at this strip circuit. All right. In real life, this is really what's going on. We have a control board. We have line 1 going in and neutral going into the board. L1 and neutral. If I told you to go check for power going into the board, where on that board would you test?
I check J7-1 to J7-3.
So you'd have a plug here, and it would have 1, 2, 3 positions, but line 1 and neutral is on 1 and 3, right? That's what that means. Now we got a shifter assembly. And in the next class, I'm going to get more detailed. I'm actually going to use parts of machines more and how they work. So here's a shifter assembly. We have 7-pin plug here, I think. So you got 1, 2, 3, 4, 5, 6, 7 pins. And we're not using pin 1, so pin 1 is dead. Pin 2 and 3 is going to the main board on a plug. What is this plug here?
J16.
J16. It could be J2, right? So this is J16. And how many wires do we got to J16? Two of them, right? And that's pin 1 and 2. So I'm not using pin 1 here, but pin 3 is going to pin 1, and pin 2 is going to pin 2. Does that make sense? So this is 1 and 2. This is 1, 2, 3. So on this plug here, pin number 2 is going to J16 2. So this 2 is going to this 2. That wire is this wire. Okay? Now 3 to 1 is this one, 3 to 1. Now I have another plug on the main board. And I'm going to use the actual parts of the machine in part 2 of this. And this plug is called what?
J2.
J2. And how many pins do I have on there? At least what?
4.
1, 2, 3, 4. And so pin 5 goes to 3. So if that's 3, that's 4, 5, 6, 7. 5 is going to 3. So that is this wire. 4 is going to 4. Wow, they match up. 4 goes to 4. 7 to 1. So 7 goes to 1. And 6 to 2. And that's how it would be connected between the two boards, the shifter and the main board. Now, what other information could I get from looking at this? I'm going to erase these lines just to... Well, let me point it out to you. First of all, this circuit is 120 volts. Is this circuit down here 120?
No.
No. Okay. So how much voltage is that section?
Is it 13 DC?
That is correct. So if I was going to test it with my meter, let me get my meter leads. They're over here. Hold on a second. Where would I put my meter leads? I wanted to check voltage from the main board.
Main board to where?
Going to our optical sensor.
Okay.
Or 13 volts. That's what, sorry, we were talking about that low voltage.
Okay. J2, 2 to J2.
I wouldn't go to J22. That's over here. That says RPM input. So in other words, that is the rotation of the motor is being input to the main board at that point. This position here is the shifter position, and that's really agitate or spin. If it's in one position, it's agitate. The other position, it's spin, and that's how the main control board knows that that switch is in the right place for that circuit. So then where was voltage coming in? It's over here on J2, 3, and 4. So I have a black and red meter lead. Is it important that they go on in a specific way?
Yeah.
Okay, so which one goes where?
The red.
Go ahead, Ricky. I guess you said first.
Black goes to ground.
Okay, so black goes to ground, and the red goes to the positive. And just listen, when we talk DC, just think of like a car battery. Okay? The car battery, the red's positive, the black's negative. Now that is important because on your meter lead, let me just show you real quick one thing. I'd just like you to hold on. I'm getting an image of a meter here. Let's add this meter here. Oh, that didn't want to copy. We'll try it one more time. Let me just do this. I was trying to copy and drag it over. The thing doesn't want to drag. If you stop being blue. Now if you look at this meter, and this is important, you have 3 holes for your meter leads. The black one is common, and the red one to the right here is your positive. Look, this is what this says on your meter. This is plus, being positive. It does voltage, ohms, diodes, so on your diode setting up here, and it's your continuity tester, which means it'll beep. MA, that is the Greek microfarads, MA, and then the little MA, which is milliamps. That's, if you're going to do any one of those tests, that's where you keep your meter leads. And in most meters, that's where you keep your red meter lead and your black meter lead. The only time we would take the red meter lead out is if we're measuring 10 amps. And I'm going to tell you right now, I've never used a meter like this to measure amperage, because that has to be in series with the load, and I don't want to even get into that. But when we're testing the DC voltage, you want to make sure that the red is in the red and the black is in the black, because when you read the voltage here, you see this little minus sign under the AC? That'll come on and it'll say negative 13 volts if you have the meter leads backward. The nice thing about a digital meter is that if you're on DC voltage and you have it backwards, it doesn't hurt the meter. It just says negative instead of positive. So guys, that would be it for today. What I would like you to do, before I break away, I'll ask if you got any questions, but I'd like you to do that first book that I sent out in the email with all the symbols. If you have questions, remember the back of the book has the answers. If you just don't want to print it, waste all that paper and ink, just try to get a piece of paper and write your answer number 1 and write whatever they want you to do, and try to practice those symbols, because practice is going to make you better at it. If you just leave and say, oh, I went to his class, I'll wait for 2 weeks for him to give another class, you're not going to get anything if you don't on your own study these. And then out of the blue, just go online and search for a random diagram and see if you can just look at it and see what the parts are. Not necessarily all the circuits, but just look at the symbols and see if there's anything you've never seen before, and if that book can show you. And then if you find something you don't understand, let me know, and then we'll discuss it in the next class. But otherwise, do you guys have any questions for today before we log out? You're welcome, Allie.
Appreciate it, Rich. Thank you.
No problem. If you guys have a good one, like I said, I know this was a simple, basic class, but that was the idea, and we're going to get more and more really, really in-depth in these circuits, okay?
Have a great weekend, Rick.
You have a great weekend, y'all.
Weekend, man. Thank you.